Hey, this is Rick's Barber here. This is the second video on finding a way to get a simple way to feed my horizontal vertical bandsaw at a controlled rate. And if you remember from the last video, I was using this bottle, and it works pretty good. The only problem with it is it has a limited range. Other than that, certainly the price is right, and it does come down pretty slow. But I wanted something with more control, and I certainly didn't want to just do something that everybody else has done. That's no fun in that for me. But I'm not to the point where I'm willing to reinvent the wheel. So I bought this product from Home Depot. It's called an air shim. And it's a nice product. I think I'm going to use it for many things. And therefore I don't want to modify it to the point where I can't use it the way it was intended. So it can be compressed down to less than 1/10 of an inch and then pumped up with this bulb right here. And it'll lift 300 pounds. So I think it's going to be of general use. When you pump it up, it'll hold it at that height for a while, but it does leak. This valve right here will let you release the pressure immediately. If you push it down a little bit, it will lower it slowly, but not very slowly. And I tried using a C-clamp on here, and I could not compress it enough to get a controlled down feed. So what I did is I went into my irrigation supplies and I got myself a plastic tee. The pressure here is very low. It's about 12 psi. And I found that this plastic tee works fine. I did first buy a brass tee and put on brass tubing, and that works much better, but it's unnecessary. If you have these tees, they're not that expensive. Certainly less than 25 cents. And the brass tee was about $4 or $5. Furthermore, I bought a needle valve out of brass, and it didn't work at all because 1/8 of a turn took me from stop to full speed down. So I've been playing around with ways to control the pressure, and fortunately this morning and afternoon I went to the Valley Metal Club picnic, talked to a number of very smart people there. And the suggestion that I implemented was from John Harriman, and it consisted of drilling and tapping the hole with a regular tap with a point on the end, and going all the way, bottoming it out in this hole. So I drilled the hole quite a bit smaller than what's recommended for a 1032. So I wanted a nice snug fit, and it does that. There's not much play in it. As I tighten this, as I tighten the screw down, it's actually bottoming out on that tapered bottom where the threads taper down. So when I tighten it all the way down, it's pretty much closed, and I can use this the way it was intended. But if I back this off a little bit, I can get a controlled bleed out of it. So what I do, I have just a piece of wood here with a screw on the back. Probably could improve this quite a bit, but still partially proof of concept. That gives me my shelf, and it rests on the fixed jaw, which is nice because I don't want to have to be solving this for every jaw position. What I have down here is 25 thousandths steel. Now I've got 1/4 inch steel flanking it because it's not able to withstand the cutting forces without that. But I'm going to show you how I can take this blade, which is 12 teeth per inch, and I can cut this. Now, as I squeeze the bulb, I'm raising the saw up, and then I can use the built-in button and bring it down, because you want to be close. So there it's closed. And then by turning this screw, I guess you can't see. By turning that screw there, I can get finer control of the feed rate. Now, I'm not going to bore you with having it cut all the way through, but I did want to show you that it can be done. So it is just slowly cutting through that 25 thou stock just fine. So that's all I have for now. I encourage you to look into the air shim. It looks like a good tool just to have in your toolbox, whether you use it for this or not. That's all for now.